video, we will go over the steps for solving linear differential equations. Uh, solving for first order linear differential equations. We will do 6 examples. Okay, so let's talk about what a linear first order differential equation. A linear first order differential equation is an equation in the form of this: a1x times dy dx plus a naught x times y equals g of x. So if it's in that kind of form, you know it's a linear first order differential equation. As you can see, there's no real fractions, so you can't cross multiply, unlike separable differential equations. So by dividing both sides of the equation by the leading coefficient, a1x, we get this: dy dx plus a naught x over a1x y equals g of x over a1x. So basically what they did was they got rid of this coefficient because you want it in the form of, you want to get dy dx by itself by dividing by each side by that coefficient. Okay, so when you simplify, you should get dy dx plus p of x of y and q of x. So we need to know what our p of x is and our q of x. Okay, so first we got to put in this form, and then we're going to need to know the p of x and the q of x. So what about the steps/process for solving a first order linear differential equation? Step 1, put the DE differential equation in the correct form. So put it in this form. So if you have a number here, get rid of it by dividing it by itself, right? Once you have it in that form, figure out your P of t, because you're going to find what's called mu of t. Yeah, mu. Like that Pokemon Mew. This symbol is mu, and then it's going to be e of integration of P of t times d of t. So we must know what P of t is going to be. Step 3, multiply everything in the differential equation by mu t and verify the left-hand side becomes the product rule. So this is a really good idea because this determines if you actually made a mistake. If the left-hand side does not become the product rule, then you know that we've done something wrong. So that's a good way to check. Step 4, integrate both sides and place the constant of the integration on the right-hand side. Step 5, solve for yt and indicate interval of validity/uniqueness. And you have two forms. You have the homogeneous form, basically when the right side is 0, and then you have the non-homogeneous when the right side is not a 0. Okay, so let's do an example. Let's start with example 1. So example 1 says solve the first order linear differential equation, and we have dy over dx minus 3x squared y equals x squared. So first step, so the first step I would do is put it in the form of dy over dx plus p of x y equals q of x, right? That's the first step. Is it already in that form? Yes, right? You have dy dx by itself. So then the second step is find your mu. But before we do that, we got to find out what our p of x and our q of x. So what is our p of x? Our p of x is basically this thing, right? It's this whole thing. So my p of x is going to be negative 3x squared. And my q of x is going to be just x squared. Okay. Step 3, multiplied by mu. Oh wait, we haven't even done step 2. So let's find our mu. So step two, we're still in step two. Find your mu, which is E, the integration of P of X, D of X, right? So it's E, and then the integration of P of X. So my P of X is negative 3x squared dx. Now, find this. You know how to take the integration of negative 3x squared dx? That's easy, right? You just use your integration rule. This negative 3 is a constant. If you want, you can put that in front. And then just use your integration rule. So it's going to be 2 plus 1 is 3 over 3, and then bring down the negative 3. That is negative 3x cubed over 3, which is negative x cubed. Okay, so your mu of x is going to be e, and we just found out what this is. The integration p of x d of x is negative x cubed. Okay, I will not put the plus c yet. You put the plus c on at the very end at the right hand side. Okay, now that we've done step two, step three is step three, multiply everything by mu. Okay, so our mu is e to the negative x3. So step three, we multiply everything by mu. Okay, so, okay. So our mu is e to the negative 3, negative e to the negative x cubed. So it's going to be e to the negative x cubed dy dx minus mu, which is e to the negative x cubed times it by 3x squared y equals mu, which is negative x cubed times x squared. So then what we have to do is step four. We gotta kind of like, before we integrate, we gotta verify the left side that this is a product rule. So we gotta verify. So on the left-hand side, we somehow have to verify that the derivative of e to the negative x cubed times y. So if you took the product rule of this, if you took the product rule of, if you took the derivative of e raised to the x cubed times it by y, it should come out to this. If it doesn't, then we made a mistake. So if you recall, what is the product rule? It is, so we got to take the derivative of this, and you have to use the product rule. So the product rule is f prime of g plus g prime of f, right? So my f is e to the negative x cubed. And what is my f prime? Yes, it's negative 3x squared e to the negative x cubed, right? You just use the chain rule. And then my g is y. My g prime is dy dx. So f prime of g plus g prime of f, so f prime is negative 3x squared e to the negative x cubed times it by g, which is y, plus g prime, which is dy dx, times it by f, which is e to the negative x cubed. Okay, so does this thing right here equal the left? Yes, it does, right? This right here is this. This right here is this whole thing, right? So yes, we just verified it. So this next step is step 4 is we're going to integrate both sides. So you're going to, on the left side, it's the integration of dy dx of e to the negative x cubed y. And then on the right, it's the integration of x squared e the negative x cubed dx, right? Because on the right side, when you multiply mu and p of x, you get this. I just put the x squared in front. Okay, so did you know when you take the integration and then the dy dx, they cancel? So now you're just left with, yeah, the integration and dy dx, they cancel out. So now you're just left with e to the negative x cubed y equals the integration of x squared e to the negative x cubed dx. And now we're going to use substitution. So how are we going to take the integration of this? Uh, yeah, we're not going to use what is it called? Integration by parts, even though there's two multiples. I think you can just get away with it using product rule. I mean, not product rule. Use substitution. So what would be our u? Our u would be negative x cubed. My du would be negative 3x squared dx. And it looks like we have to get rid of this negative 3, right? Because if we do, you'll have x that comes out nicely. So let's get rid of this negative 3 by multiplying both sides by negative 1/3. So this is negative 1/3 du. And then over here, the negative 3 and the negative 1/3 cancel, so you're left with x squared dx. Okay. So now you're left with e to the negative x cubed y equals e to the u, and then you're going to replace x squared dx with negative 1/3 du, right? So this is a constant, so put it in front of the integration. U is what? Negative x cubed. Right. So yeah, this is what the integration is going to be. And then on the left, we have e to the negative x cubed y times by y. And then remember we said to add the plus c on the right-hand side, so that's what we're going to do. Now, is this our final answer? This is what's called our implicit solution. What if we want it in explicit? Can we put it in explicit? Meaning, can we solve for y? I think we can. So step 5 is solve for y. Okay, so how would you do it? You would divide everything by e to the negative x cubed. So this cancels, and then you're left with y equals negative 1/3 e to the negative x cubed. And then what happens here is the e to the negative x cubed cancels. So this just cancels. So you're just left with y equals negative 1/3. And then you have c over e to the negative x cubed. So how can I rewrite this? So we have an e, and then so this is a negative in the denominator. So this somehow, if you simplify this even more, this now becomes positive x cubed, right? Because this is like saying c over e to the negative x cubed is the same thing as 1 over e to the x cubed. And then you have what's called a complex fraction, and you would have to multiply both sides by e to the x cubed. So now you get c e x cubed, and then on the bottom, this cancels, right? Because you're doing it both sides. So this simplifies as c e x cubed. And I think that's it. We don't really have a interval. We don't have like a initial value, so this would be our explicit solution. And where is it continuous? It's basically a linear line. So I'm going to say it's continuous from negative infinity to positive infinity. Okay. Okay, so that was example 1. Let's move on to example 2. So example 2 says solve the first order linear differential equation of x squared dy dx plus 5xy plus 3x squared 5 equals 0. So the first step is put it in its correct form. So step 1. Put it in this form. So what do we have to do? We have to somehow get rid of this x squared. So I'm going to divide everything by all sides by x squared. Okay. So this cancels, and then you're left with dy dx plus, over here the x cancels, and then you have 1x, so that's just going to be 5xy. Oops. And then I should have, oh, let's just simplify this. 3x5 over x squared, that's 3x cubed. And then on the right, still 0. What I have to do is, yeah, this is still plus, not minus. What I have to do is move this 3x cubed. I should have done that first. Move this 3x cubed to the right. So I'm going to subtract negative 3x cubed. So you get dy over dx plus 5 over x y equals negative 3x cubed. Okay, what would you do next is, so we have it in the correct form. Let's write out our p of x and our q of x, because we'll probably need it. So my p of x is this whole thing, right? 5 over x. And my q of x is this whole thing. Okay. Okay, now step 2 is find your mu. So your mu is e raised to the integration of p of x d of x. So that is going to be e integration, and then my p of x is 5 over x dx. So let's find what this is. What is the integration of 5 over x dx? That's easy, right? This 5 is a constant, so you could take that out, and then now you have 1x dx. What is the integration of 1 over x? It's the ln of absolute value of x, and then you have a 5. Okay. So it's going to be e integration of p of x d of x, which is, oops, we've already solved that. So it's just going to be e raised to the 5 ln of x. Uh, can we cancel the ln and e immediately? Not quite. You have this 5 in front of the ln. We have to somehow use our log rules. What happens when you have a number in front of a natural log or a log? Well, when you're expanding, it's your power, right? So you can rewrite this as e to the ln, and then I know this is going to be positive, so it's going to be x to the 5, or x to the 5. Now you may cancel the e and the ln, so now you're just left with x5. So your mu is x5. Okay, so we're going to need that. Step 3 is multiply everything by mu. Okay, so our mu is x cubed, I mean x5. Here, u of x times p of x times y. My mu of x is x5. My p of x is 5 over x times by y. For here, what's mu of x times q of x? My mu of x is x5, and then my q of x is negative 3x5, 3x cubed. So should we simplify that? I think we could. What's x5 times negative 3x cubed? That's going to be negative 3x. And when you're multiplying, you're adding, so 5 plus 3 is 6, 7, 8. Okay. Now let's do, we got to verify the left side is the product rule. Yeah, so you got to verify before we move on, before we take the integration. Please verify left side is a product rule. Okay, so what I mean is, does x, if you take the derivative of x5 times y, right? It gives you the product rule. You have to use the product rule, and does it expand to this? I think so, because what is the product rule? F prime of g plus g prime of f, right? So my f is x5. My f prime is 5x to the 4th my g is y, my g prime is dy dx. F prime times g, so f prime is 5x to the fourth times it by g, which is y, plus g prime, which is dy dx, times it by f, which is x5. So does this right here give you this? Yes, it does. If you simplify this x5 times x4, that cancels, that becomes 4. So you have 5x fourth times y, so that's why that, and then this x5 times dy dx, yes. So it's been verified. Okay, step 4, integrate both sides. Okay, so we said that we simplify the right and it gives you negative 3x8. So as you recall, an integration and a derivative cancels. So now you're just left with x5y. And then on the right, this is not too bad, right? What is the integration of negative 3x8? Well, negative 3 is a constant, so you could take that out. And 1 is the integration of x to the ninth. It's x9 over 9 times it by negative 3. And don't, I guess you could plus and put the plus c. So over here, negative 3 over 9 can be reduced. So that's negative x9. 9 divided by 3 is 3. Is this your final answer? No, we can try solving for y. So step 5, solve for y if you can. So all I got to do is divide everything by x5. So negative x9 over 3 is negative x9 over 3 divided by x5, or when you have like a complex fraction, and I guess if you multiply this by 3, you get negative x9 over 3x5. That simplifies as negative 1/3 x. 9 minus 5 is 1, 2, 5. Negative 1, negative 1/3 x4. And then c over x5, that could be written as c x to the negative 5. So your final answer is going to be y equals negative 1/3 x4 plus c x to the negative 5. And then this is your explicit general solution. Uh, what kind of graph is this? Because we need to find it like where it's continuous. Uh, if you simplify x to the negative 5, that's 1 over x5. Now you have what's called a rational function. And how do you find the domain of a rational function? You set the denominator to 0 and solve for x. So x can never equal to 0 because that's your vertical asymptote. So it's continuous from negative infinity to 0, union 0 to infinity. Okay. Okay, let's move on to example 3. Okay, example 3, yeah, y prime of 2y plus x squared plus 5. What should I do? Well, y prime, we should put it in the correct form. So step 1, put it in the correct form. So what do we have to do? Well, I know that the y prime is the same thing as dy dx. And then I also know if I move this 2y to the left, so that would be negative 2y. And then this stays the same. Now, I think we have it in the correct form. Yeah, we do. So let's first figure out our p of x and our q of x. So my p of x is negative 2. And my q of x is this whole thing, x squared plus 5. Okay. Step 2, find your mu. So your mu is e to the integration of p of x dx. What is our p of x? It's negative 2. So this is going to be e to the integration of negative 2 dx. Right? Now, we know how to take the integration of negative 2 dx. It's basically negative 2x. So that's e to the negative 2x. So that is your mu. Okay, step 3, multiply everything by mu, right? Okay, so it's going to be, our mu is e to the negative 2x, so it's e to the negative 2x dy dx plus mu is e to the negative 2x times p of x, which is p of x. Negative 2. And then you have this y, and then mu of x times q of x, so it's going to be e to the negative 2x times q of x, which is x squared plus 5. Okay, once we do that, we got to verify. We got to verify the left of the product rule. Verify that if you take the e to the negative 2x times y, and if you take the product rule or take the derivative of that, it should give you this. I think it is because my f is e to the negative 2x. My f prime is negative 2 e to the negative 2x. My g is y. My g prime is dy dx. Okay, so if you apply the product rule, f prime of g plus g prime of f prime is negative 2 e to the negative 2x times it by g, which is y, plus g prime, which is dy dx, times by f, which is e to the negative 2x. And yeah, this exactly looks like the left side, so verified. Okay. The next step is integrate both sides. So on the left side, it's the integration of e to the negative 2xy prime of the integration of x squared plus 5 e to the negative 2x dx. So as you recall, a derivative and integral cancels, so now you're just left with e to the negative 2x. And over here, it's going to be the integration of x squared plus 5 e to the negative 2x dx. So how do we take the integration of this x squared plus 5 e to the negative 2x dx? Can we do a u substitution? No, no, we can't. So they're multiplying two products, so it's most likely we're going to do what's called integration by parts. So if you call elite or elite or elite, they all mean the same thing. So you can use elite or light, elite. They're the same thing. So the I stands for inverse. The L stands for log. The A stands for algebra. So I think we'll have to use a tabular method because integration by part will be used twice. So yeah, we're going to use the tabular method. So go ahead and make your table for the tabular method. It's going to be sine du dv. That's going to be plus, and then this is going to be x squared plus 5. And then my dv is e to the negative 2x. And then the sign is going to be negative. The derivative of x squared plus 5 is 2x. Then the derivative of e to the negative 2x is negative 1/2 e to the negative 2x. And then you have a plus. The derivative of 2x is 2. The derivative of negative 1/2 e to the negative 2x is positive 1/4 e to the negative 2x. And the sign changes, and then this becomes the derivative of 2 is 0. The derivative of 1/4 e to the negative 2x is negative 1/8 e to the negative 2x. Okay, so if you recall, this goes with this goes with this, and 2 goes with negative 1/8. So it's going to be, so this is the right side. It's going to be positive x squared plus 5 times negative 1/2 e to the negative 2x. And then the sign changes to a negative, so it's going to be minus, and then it's going to be 2x times 1/4 e to the negative 2x. And then keep on going, the sign changes to a positive, and it's going to be 2 times negative 1/8 e to the negative 2x. And then don't forget the plus c. So this is the right hand side, right? What you would do is so on the left you're going to get e to the negative 2x y, and then if you kind of clean this up a bit, or yeah, put the -1/2 first. So this would be -1/2 x squared plus 5 e to the -2x minus 1/2 x e to the -2x minus 1/4 e to the -2x plus c. And then if you solve for y, you would have to divide everything by e to the -2x. So this cancels, and then you're left with y equals -1/2 x squared plus 5, -1/2 x minus 1/4 plus c e to the 2x. And this is your general solution. Okay, so that's your final answer for example 3. Should we take a break or should we continue? I guess we can continue. Let's move on to example 4. Okay, so this one is a little bit different. Now we have an initial condition. So example 4 says solve the first order linear differential equation given an initial condition. So we have this whole thing. Cosine of x times dy dx plus sine of x times y equals 2 cosine cube x sine x minus 1. And then we are given an initial condition of pi over 4 equals 3 radical 2, right? And our boundary is from here. So step 1 is put it in the correct form. So what do we have to do? I think all we got to do is just like divide everything by cosine of x, right? So this cancels. So you're left with dy dx plus tan of x times y equals, we hear the cosine q of x divided by cosine of x just cancels, so you're left with 2 cosine square of x sine of x. And then on the right, -1 times cosine of x is -1 over cosine of x. Okay, I think we could simplify the right. So this, what is 1 over cosine of x? That is the same thing as secant x, so it's minus secant x. Okay. Now we did this so we could find our mu. So wait, what is our mu? So yeah, step 2 is find your mu. So your mu is e to the integration of p of x d of x. So my p of x is, what is my p of x? It is tan of x, right? So you can say tan of x, or you can also say sine of x over cosine of x, right? They're the same thing. So it's going to be mu of x equals e, and then the integration p of x is sine of x over cosine of x d of x. And then how do you take the integration of this? You could use u substitution. So your u is cosine of x, and my du is negative sine of x d of x. And I think we have to get rid of this minus, so we're going to multiply everything by -1. So it's negative du equals to -1 times negative is positive. So this would be 1 over u, and then you can replace sine of x dx with negative du. And then you have this minus here, so put that front. And what's the integration of 1 over u? It's ln of u, which is cosine of x. Then you have a minus here. So wait, that simplifies as e to the negative ln of the absolute value of cosine x, right? And you have this minus, so we put that in front of the power. So it's going to be, because like when you have a minus and you expand, you put the, whatever the coefficient as a power. So it's going to be e to the negative ln of the absolute value of cosine x. Oops, I mean, put this -1 in front, so it'd be to the power of -1. So now what you can do is get rid of the e and the ln. So that cancels out as, so your mu of x is cosine of x to the -1. And we know that cosine of x is the same thing as 1 over cosine of x, right? And then what is 1 over cosine of x? That's the same thing as secant of x. So your mu is secant of x. Okay. Okay, well, what I do next is, now we've found our mu. Now step 3, multiply everything by mu of x. Okay, so this would be, so our mu of x is c of x, secant of x. So it's secant of x times dy dx plus this is secant of x times p of x, which is tan of x times y, and then on the right, mu of x times q of x is secant of x times q of x, which is uh, q of x. of this whole thing. So yeah, it's going to be secant of x times 2 cosine square of x sine of x uh, minus secant x times secant of x. Oops. Okay. So the next step is verify the left side of the product rule. So does this, if you do secant of x times y, and if you take the product rule or take the derivative of that, you should get secant of x times dy dx plus y times secant of x times tan of x. So this now is the same thing as the left side, so it's been verified. So what we have to do is before we take the integration of both sides, let's simplify the right side. So it's going to be 1 over cosine of x times 2 cosine square of x sine of x minus secant square of x. So that simplifies as 2 cosine of x times sine of x minus secant square of x. Okay, so this is, if you simplify and FOIL out the right side, this is what you get. So step 4, integrate both sides. Okay, so on the left, it's dy dx of secant x times y equals the integration of 2 cosine of x sine of x minus secant square of x. So did you know that 2 cosine times sine of x is a double angle? So this is a double angle, and that's the same thing as sin of 2 of x. So on the left side, the integral and the derivative cancel, so you're just left with secant x times y, and then on the right, it's going to be the integration of, so this simplifies as sine of 2 of x minus the integration of secant square of x. This is not too hard. This is not complex. How do you take the integration of sine of 2x? You would have to do u substitution, right? So my u would be 2 of x, and my du would be 2 dx. And we have to get rid of this 2. So to do so, we're going to multiply both sides by 1/2. This is 1/2 du equals, the 1/2 cancels right left with dx. So it would be the integration of sin of u, and then you can replace dx with 1/2 du. So 1/2 is a constant, put that in front. And then over here, what's the integration of secant square x? That's just tan of x. And then, what's the integration of sine of u? It's negative cosine. So it's going to be negative 1/2 cosine of u, and our u is 2x minus tan of x plus c. And then on the left, it was secant x times y. Okay, now we do have to solve for c because we have an initial condition. So step 5, plug initial value. Okay, so this is your x, this is your y. So it's going to be secant of x, which is pi over 4, times it by y, which is 3 radical 2, equals to negative 1/2 cosine of 2 times x, which is pi 4, minus tan of pi over 4 plus c. Okay, so secant of pi over 4 is 2 radical 2, times it by 3 radical 2, equals to negative 1/2 cosine of 2 pi over 4, that's negative 1/2 cosine. 2 times pi over 4 is just pi over 2, minus tan of pi over 4 is just 1, plus c. By this, cosine of pi over 2 is 0. Then you still have this negative 1 plus c. Simplify the left, what's this? 2 times 3 is 6 radical 2 over radical 2. So that cancels, so you're just left with 6 equals to negative 1 plus c. Add c, add 1, so c equals 7. Okay, now that we have our c, so now it should simplify as secant of x times y equals to negative 1/2 cosine of 2x minus tan of x plus 7. And then you're going to solve for y. So, because our c is so solve for y. So get rid of this secant of x, or divide everything by secant of x. So this cancels, and now you're left with y equals so if you simplify this a bit more, uh, it would be negative 1/2 cosine of 2x, and then divided by secant of x, that just becomes positive cosine of x, right? I don't have to explain it. Like secant of x is the same thing as 1 over cosine of x, and then complex fraction, etc. Minus tan of x over secant of x is the same thing as tan of x times cosine of x, plus 7 over secant of x, that's the same thing as 7 over cosine of x, or 7 times cosine of x, right? Secant of x somehow simplifies as cosine of x. And I think this is it. This is our final answer. Or wait, we can do something, right? What can we do? So did you know that tan of x is the same thing as sine of x over cosine of x? And then you have this cosine of x. This cancels, so you're just left with sine of x. This is your final answer. So this is your explicit solution. Okay, let's move on. That was a long one. Let's move on to example 5. So example 5 says, solve the first order differential equation by giving the initial condition. So we have x plus y times y prime plus y equals ln of x, where y of 1 equals 10. So we have an initial condition. So step 1, first step is solve for dy dx. Put it in the form. Okay, so what do we have to do to get it in this form? We have to get rid of this x plus 1. So we're going to divide both sides by x plus 1, or everything by x plus 1. So you get dy, y prime is the same thing as dy dx, plus this is the same thing as 1 over x plus 1 y. And then this is the same thing as ln of x over x plus 1. Okay, now what we'll do is find our px and q of x. So my p of x is 1 over x plus 1. And then my q of x is ln of x over x plus 1, right? So once we've found that, step 2 is find your mu. So it's going to be e integration of p of x, which is 1 over x plus 1 dx. And 1 over x plus 1 is, how do we take the integration of that? It's simple, right? We would have to do u substitution. So my u is x plus 1. My du is 1 dx. So this is going to be the integration of 1 over u du. And then we know that that's going to be the ln of x plus 1. So it's going to be e to the integration, or the integration of 1 over u is the same thing as ln of absolute value of x plus 1. And the ln e cancels, you're just left with x plus 1. So that is your mu. Okay, now that we have our mu, step 3 is multiply everything by mu. So it's going to be, if our mu is x plus 1, it's going to be x plus 1 times dy dx plus mu of x times p of x times y. So that's going to be x plus 1 times 1 over x plus 1 times by y. And then u of x times q of x is x plus 1 times ln of x over x plus 1. Okay. So on the right side, the x plus 1 cancels, so you're just left with ln of x. The left side, you got to verify that if you took the derivative of x plus 1 times it by y, if you took the derivative of that, you should get this. And I think that's true because your u is x plus 1. I mean, not my u, my f is x plus 1. My f prime is 1. My g is y. My g prime is dy dx. Okay. And yeah, so it's going to be particle is f prime of g plus g prime of f. So f prime is 1. My g is y. My g prime is dy dx. And my f is x plus 1. And yes, that verifies the left. This whole thing is now the left side. So did it correct. Okay, step 4, integrate both sides. Okay, we got dy dx of x plus 1 y equals the integration of ln of x dx. Okay, so as you can see, the integration and the derivative cancel, so you're just left with x plus 1 times y. Now, what about the right side? How do we take the integration of ln of x? You have to do integration by parts, right? So elate, annihilate, and we don't have inverses. I don't have logs. Wait, we do have a log, right? Or a natural log. So my u is going to be ln of x, and my dv is the leftover, which is 1 dx. My du is 1 over x dx, and my v is the integration of 1 dx. It's just the integral of 1 dx is just x. And so you do integration by parts, so it's going to be uv minus the integration of v du. So my u is ln of x, my v is x, minus my integration of v du. So my v is x, and my du is 1 over x dx. So over here, ln of x times x is just x ln of x minus the integration x times 1 over x just becomes 1 dx. And then the integration of 1 is x. And then don't forget the plus c. This is the right, and then the left was x plus 1 times y. So we do have to plug in our initial condition. Our initial condition is y1 equals to 10, or your x is 1 and your y is 10. So it's 1 plus 1 times it by y, which is 10, equals x, which is 1, ln of x is 1, minus 1 plus c. 1 ln of n is 0, minus 1, so that's negative 1 plus c. 1 plus 1 is 2, times it by 10, that's 20. Add c, so you add 1, you get c equals to 21. So you get, so now it's going to be x plus 1 y equals to x ln of x minus x plus my c, which is 21. Then I would solve for y. So I would have to divide everything by x plus 1. And when you simplify, you should get y equals x ln of x over x plus 1 minus x over x plus 1 plus 21 over x plus 1. And because it's like a rational function, our interval, where is it continuous? Uh, everywhere except -1. Because if you set set the bottom to 0 and you solve for x can never equal to -1. Or basically x must be greater than 0. Yeah, because you can't put 1 here, that'll make it ln of 1 is 0. So it has to be greater than, can't equal to -1, and it has to be greater than 0. So your interval validity is from 0 to infinity. Okay, I guess we can stop here. I think that was the last example. Okay, we'll stop here.